The clam harvesting and aquaculture industry along Japan's coastal areas is a vital sector, especially in regions rich in high-quality clam resources such as Hokkaido and the northern seas of Japan. One of the primary methods for harvesting clams is bottom trawling, where nets are dropped to the seabed to collect clams. However, this method can significantly impact the seabed environment. Another common technique is cage farming, which uses mesh cages or floating rafts on the water surface. In this method, clams are raised in suspended cages in seawater and harvested once they reach the ideal size. This approach has minimal environmental impact and allows for better quality control. The digging method involves using tools to extract clams from the seabed, typically by dragging equipment across areas with high clam density. Clam harvesting usually takes place during the summer and autumn months, from July to October, when clams reach optimal size and meat quality. In certain regions, clam harvesting is strictly regulated by fishery protection laws to prevent overfishing and conserve marine resources. Shelling clams is typically carried out at ports or processing plants near the coast, where the clam meat is removed and thoroughly cleaned to eliminate impurities. After cleaning, clams can be packaged and stored at low temperatures or frozen to ensure quality during transport to domestic and international markets. Offshore clam harvesting faces numerous challenges, including climate change, environmental shifts, and the risk of resource depletion due to overfishing. Japan has implemented sustainable resource management measures, such as limiting the number of clams harvested, managing fishing seasons, and developing modern aquaculture techniques. Advanced technologies are employed to optimize clam harvesting and farming, ensuring both efficiency and sustainability. Floating cages and suspended nets are among the most sustainable and widely used clam farming methods in Japan. These cages are designed to hang in the seawater, allowing clams to grow naturally without harming the seabed environment. The cages or nets are often attached beneath floating rafts or fishing vessels, ensuring clams have constant access to nutrients from the seawater. Water quality monitoring employs modern sensor technologies to measure environmental factors such as temperature, salinity, and pollution levels, ensuring optimal conditions for clam growth. Some advanced systems allow for automated clam harvesting, reducing the need for manual labor and increasing productivity. GPS and sonar technologies are used by fishermen to locate and track clam beds on the seafloor. Sonar can scan the seabed to determine clam density, saving time and effort without the need for diving or net dragging. After harvesting, fresh preservation techniques are essential to maintain product quality during transportation. Quick freezing technology is used to freeze clams immediately after harvesting, preserving their freshness and nutritional value. Some producers also use dry ice or liquid nitrogen for international transport, ensuring the clams remain fresh and undamaged. Japan places great emphasis on protecting natural clam resources, implementing a range of measures to manage sustainable harvesting. These regulations help minimize environmental impact and maintain ecological balance in fishing areas. Size and quantity regulations prevent the harvesting of juvenile or undersized clams, ensuring the long-term sustainability of clam stocks. Certain areas are designated as off-limits during specific seasons to protect the environment and allow clam populations to recover. Japan also conducts extensive research to closely monitor the population and health of clam communities, allowing for timely adjustments to management measures. The commercial clam harvesting industry in Japan has a long history and has evolved into a major industry, combining traditional fishing methods with modern technology. Commercial clam harvesting primarily includes two main methods: wild clam harvesting and clam aquaculture. Wild clam harvesting mainly occurs in Japan's coastal waters, where clams naturally grow on the seafloor, using various techniques for efficient harvesting. The most common technique is bottom dredging, which uses a net with a metal frame, a cutting blade at the front, and a mesh bag at the back. As the net is dragged along the seafloor, the blade cuts into the sand and mud, collecting clams into the mesh bag. The net is lowered from the fishing vessel and dragged through clam-rich areas. Once the net is full, it is pulled back onto the ship. However, this technique can disturb the seafloor and affect the ecosystem where clams live. To minimize this impact, Japan has implemented strict regulations, including restrictions on fishing areas and seasons, as well as the use of more environmentally friendly equipment. Commercial clam fishing vessels in Japan are equipped with modern machinery to enhance efficiency, capable of processing hundreds to thousands of tons of clams per trip. Modern vessels are fitted with powerful winches to lower and pull up the nets. Conveyor systems help transfer the clams from the net into storage quickly and efficiently. Some vessels are also equipped with onboard cleaning and preliminary sorting systems. Fishermen are only allowed to harvest clams that meet a minimum size requirement to ensure juvenile clams have the chance to grow and reproduce. Specific fishing seasons are established to prevent overfishing and to support the recovery of clam populations. In addition to wild harvesting, Japan has developed clam aquaculture, especially in northern waters like Hokkaido, where conditions are ideal for clam growth. Cage farming is a common and sustainable method. Carried out in controlled water areas, juvenile clams are raised in nursery cages until they are large enough to be released into the sea. They are then placed in mesh bags or cages and suspended on underwater cables. These cables are fixed at depths of 10 to 30 meters, where strong currents provide a natural food supply for the clams. During the cultivation process, fishermen regularly inspect the cables to remove parasites and maintain a clean environment. Clams take about 2 to 3 years to reach market size before being harvested. This method has minimal impact on the seafloor and ecosystem, provides consistent clam quality, and allows for controlled production. A similar method is raft farming, where clams are placed in cages suspended beneath floating rafts instead of cables. This technique allows fishermen to monitor and harvest clams as needed more easily. Another approach is bottom seeding, where clams are released directly onto controlled seafloor areas, allowing them to grow naturally with minimal human intervention. After a period of time, fishermen use light equipment to harvest the clams once they reach commercial size. This method mimics the natural environment and has low ecosystem impact, but harvesting is more difficult and usually takes longer compared to cable or raft farming. After harvesting or cultivation, the processing and treatment of clams play a crucial role in ensuring product quality. Clams harvested using bottom trawls are brought aboard fishing vessels, where sorting systems are used to select those that meet the required standards. For clams cultivated using hanging lines or rafts, once they reach a sufficient size, fishermen pull up the lines or cages and separate the clams either on the boat or at processing plants. On board, the clams are cleaned to remove mud and organisms attached to the shells, then sorted by size and quality for further processing or export. After cleaning, clams may be exported fresh, frozen, or processed into other products such as dried clams or clams preserved in oil. Rapid freezing technology is commonly used to preserve clams, ensuring freshness and nutritional quality during transportation. Japan employs various sustainable management measures, including controlling the volume of harvested clams, restricting fishing areas, and promoting clam aquaculture to reduce pressure on natural resources. These measures not only protect the environment, but also ensure a sustainable supply of clams for the future. Training and supporting fishermen in adopting sustainable fishing methods helps maintain the long-term viability of the industry. Japan leads in the development of sustainable clam industries, balancing environmental protection with meeting global consumption demands. To ensure the sustainability of the clam fishing industry, training and skill development for fishermen are essential. Japan implements various educational and support programs to help fishermen master advanced fishing and aquaculture techniques. Training courses on modern aquaculture technologies, raft farming methods, environmental monitoring, and product preservation enable fishermen to adopt sustainable practices in harvesting and farming. Education on marine resource management helps fishermen understand the importance of ecosystem protection and complying with environmental regulations, raising awareness of their role in conserving marine resources. Local governments and related organizations provide financial and technical support to help fishermen upgrade their equipment, adopt new technologies, and improve production processes. These policies create opportunities for small-scale fishermen to participate in the modern supply chain. In some regions, fishing communities collaborate, sharing experiences, knowledge, and resources. These communities co-manage marine resources to ensure sustainable harvesting and maintain the prosperity of the industry. Japan also implements various measures to encourage younger generations to join the fisheries sector through training programs and startup support in clam farming and processing. Clam processing technology plays a vital role in ensuring the quality of the final product. Japan has adopted many technological advancements to improve quality and optimize processing procedures. Many clam processing plants utilize automation technology to enhance efficiency and reduce reliance on manual labor. Automated clam shelling machines quickly and accurately separate the clam meat, increasing productivity while maintaining meat quality. Automated cleaning systems use high-pressure water and advanced cleaning technology to ensure the product is clean and safe. Individual quick freezing, IQF technology, helps preserve freshness and nutritional value, prevents ice crystal formation, and maintains the firmness of the clam meat. After cleaning, clams are often vacuum-packed to extend shelf life without the need for chemical preservatives. Japan implements strict quality control standards for exported clams, including microbiological and chemical testing to ensure the products are free from bacterial contamination or harmful chemicals. Clams are sorted by size and thickness to ensure uniformity in each shipment. To expand its market, Japan invests in international marketing and promotion of clams, emphasizing their quality, freshness, and high production standards. Japanese clams are promoted as a premium product, known for their unique flavor and sustainable production process. Renowned Japanese clam brands appear in high-end restaurants in the US, China, and many other countries. Many Japanese clam producers have achieved international certifications such as HACCP, Hazard Analysis and Critical Control Points, and ISO Food Safety Standards, which enhance global consumer confidence in the quality and safety of the products. In addition to supplying fresh and frozen clams, Japanese producers have developed various value-added clam products to meet diverse market demands. Dried clams are a popular product, not only in Japan but also in other countries, used in cooking or as a snack, retaining their distinct flavor and being easy to use. Clams marinated in oil and canned clams in special sauces are also increasingly favored, offering convenience and a unique culinary experience for consumers. Clams are an essential ingredient in Japanese cuisine, used in many dishes such as sushi, sashimi, grilled or stir-fried dishes. Japanese clams are known for their sweet taste, tender and chewy texture, enhancing the value of these dishes. The clam fishing and farming industry not only brings significant economic value, but is also deeply tied to the culture and traditions of many coastal regions in Japan. A new generation of fishermen continues to inherit the practice of clam farming and harvesting, maintaining customs and festivals related to this industry. Japan's coastal clam industry has become a symbol of sustainable development, environmental protection efforts, technological advancement, and international brand building, making Japanese clams a beloved product in the global market. Underwater sensors are installed on the seabed to monitor critical environmental indicators such as temperature, salinity, and dissolved oxygen levels. This information allows fishermen and managers to promptly detect environmental changes and adjust harvesting or farming methods accordingly. Satellite data helps analyze environmental conditions on a large scale, identifying suitable areas for clam farming or harvesting without degrading marine resources. Modern Japanese commercial clam fishing vessels are equipped with advanced GPS and sonar systems to locate clam beds on the seafloor. Sonar can detect seabed structures and pinpoint clam locations, optimizing the harvesting process and minimizing environmental impact. This system enables fishermen to accurately target clam beds without dragging nets through sensitive areas, thereby reducing disruption to the seabed and minimizing effects on other ecosystems. On modern vessels, automated machinery supports the harvesting, cleaning, and sorting of clams right on board, improving labor efficiency, and ensuring clams remain in optimal condition from harvest to transport. Thanks to onboard automation and mobile technology, clams can be preserved at ultra-low temperatures throughout the journey, reducing spoilage risk and ensuring high quality for export. Japan also focuses on developing certified sustainable clam harvesting practices, ensuring that the industry does not negatively impact the marine environment and can operate over the long term. The MSC, Marine Stewardship Council certification, is an internationally recognized standard for sustainable seafood harvesting, and many Japanese clam fisheries have achieved this certification by adhering to strict rules that protect marine resources and prevent the depletion of wild clam populations. MSC-certified areas have strict management systems in place to monitor and protect clam populations, including setting annual catch limits, banning harvesting during certain seasons, and implementing other ecological protection measures. Regular training programs are organized for fishermen, emphasizing the importance of sustainable harvesting and helping them understand the long-term benefits of protecting clam resources. Japan combines natural clam harvesting with aquaculture to reduce pressure on wild populations and ensure the sustainability of the clam industry. This sector faces challenges such as climate change, increasing demand, and the risk of resource depletion. But with the integration of advanced technology, sustainable management, and fishermen education, Japan can maintain the long-term growth of the industry. Japan invests heavily in research on the impact of climate change on marine ecosystems, including changes in the conditions necessary for clam development. Through this research, scientists can promptly propose adaptive measures, such as adjusting farming locations or improving clam cultivation processes to cope with changes in ocean temperature. Shifts in seawater temperature can affect clam survival. Researchers are exploring new harvesting and aquaculture techniques to ensure clam development is not adversely affected by climate change, while also expanding export opportunities into new markets.